All right, here's a quick video on evaluating an integral using U-substitution. Integrate x squared times square root of 1 plus x to the third from 1 to 2. Let's first look at the graph. Y equals x squared times the square root of 1 plus x to the third. Let's hit our graph button. Let's see what this looks like. All right, it's growing very, very rapidly. So we want to take this curve and find the area under it from 1 to 2. So let's get a better idea of the area that we're looking to find. We can change our window up just a little bit so that we can accurately see everything we need to see. It's hard to interpret what we have right now in terms of the area that we're looking for. So we can zoom in a little bit and see that area. So to do that, what I first want to do is go to my table. When I go to my table, I notice when x is 2, my y value is 12. So that's going to help me change my window up because I at least want to see 12 on the y-axis. All right, so let's go to window. I'm going from 1 to 2 on my x-axis, but I still want to see the y-axis. So I'm going to say x min 0, x max, I want to go to 2. Y min we'll take from 0. Now we at least want to see 12, so let's go up to 15. Now let's graph. Now we have a better picture of the area that we're looking for. We're looking for the area from 1, here's x equals 1 right here, to 2. So if we shade this in all right here, that's the area that we're looking for. Remember, definite integrals can be interpreted as area under a curve. Now let's see how we can find the exact area under that curve using the fundamental theorem of calculus. But in order to do that, we have to use U-substitution. So let's look at the problem. Now here's a common mistake I've seen students use. There's no way you can break this product up and do this. That is a big, big, big no-no. Do not do that. So instead what we want to do is use U-substitution. What is that? Well, let's take U and let's say that U is equal to 1 plus x to the third. So the inside of that square root. Now find the derivative of U with respect to x. Du over dx is equal to the derivative of 1 with respect to x is 0. The derivative of x to the third with respect to x is 3x squared. Now, whenever you're using U-substitution, we're not going to write it as du over dx is equal to 3x squared. Instead, we're going to take that dx and move it over and multiply it by that 3x squared. So it's going to look like this. So du is equal to 3x squared dx. Now, the goal with U-substitution is being able to take all those expressions with x and make a simple substitution so that we can integrate with respect to u. Okay, so how do we do that? Well, notice on the inside here, this is exactly what I set u equal to. Not u, but letter u. So there's the square root of u when I make that substitution. But now I have to substitute something in for this x squared and that dx. Well, notice x squared dx is sitting right here. So the way I like to do this is I would divide both sides of my du by 3. What that does is take du over 3, that's equal to x squared dx. So now I have something to substitute in for x squared dx. Okay, so let's see these substitutions. So I have the integral. Now my limits of integration are going to change because my variable is changing from an x to a u. I need to be very careful to realize that these are x values. Okay, so now that I'm changing my variable from an x to a u, I need my limits of integration to change to u values. We'll get to that in a second. Let's go ahead and make our simple substitutions. All right, so x squared dx, let's go back to orange, is equal to du over 3. So du over 3. And now inside that radical, I have the square root of u. So now I have the integral, we don't know the limits yet, of the square root of u times du over 3. So now let's find those limits of integration. If x is equal to 1, then u has to equal, well, u is equal to 1 plus x to the third. If I plug in 1 for x, 1 to the third is 1 plus 1. That means u has to be 2. So when x is 1, u is equal to 2. So there's my lower limit. Now, when x is 2, plug it in to the u function. U is equal to 1 plus x to the third. So if x is 2, 2 to the third is 8 plus 1. So u has to be 9. So let's clean this up. All right, here's what it looks like a little cleaned up. So du over 3, let's just take that 1/3 and pull it off to the side and make it a coefficient. I have the square root of u du. So it all cleans up. So now I'm only integrating 1/3 square root of u du from 2 to 9. A little easier. So let's pull out the 1/3 and let's rewrite the square root of u as u to the 1/2. There we go. Now, what is the antiderivative using the power rule of u to the 1/2? Remember, the power rule for integration says you could take the power, add 1 to it, and then divide by the power plus 1. That's how you integrate. Now, this power is a fraction, so add 1 to 1/2. You get 3/2, divide by 3/2. So we have 1/3 times u to the 3/2 divided by 3/2 integrated from 2 to 9. It still looks a little messy. Remember, when you divide by a fraction, you multiply by the reciprocal. So let's zoom down, let's scroll down. I can take this and say 1/3 times, take that denominator 3/2 and flip it, right? If I divide by 3/2, that's the same thing as multiplying by 2/3. So 2/3 u to the 3/2 from 2 to 9. Let's scroll down again. 1/3 times 2/3 is 2 over 9 u to the 3/2. Now, using the fundamental theorem of calculus, we're going to take 9 and plug it in. So I have 2/9 times 9 to the 3/2 power minus 2/9 times 2 to the 3/2 power. 9 to the 3/2, well, if I write that a little differently, it'll look like this. What I did is I took the 3/2 as an exponent and I wrote it as a root. So remember, the denominator is 2, so that means I have the square root. The numerator was 3, so I have the square root of 9 to the 3rd, and then over there I have the square root of 2 to the 3rd power. All right, so let's clean it up a little bit more. All right, what's the square root of 9? Well, that's 3. So now I have 2/9 times 3 to the 3rd minus 2/9. If you multiply root 2 to itself 3 times, square root of 2 times square root of 2, well, that's 2 times another square root of 2. So this becomes 2 square root of 2. Now 2/9 times 3 to the 3rd power. Now you can reduce this in any way you want to. I know 3 squared is 9, and so 3 squared in the numerator is going to reduce with that 9. But if you don't immediately see that, then just calculate it very carefully. 2 over 9 times 27 minus 4 over 9 times root 2. Now 2 over 9 times 27, now I can reduce that to 3 over 1. 2 times 3, 6 minus 4 over 9 times square root of 2. Now from here I can write it as one fraction if I want. I can approximate. That's what I want to do to check myself in the calculator. So let's approximate this to see what it is. round 2 decimal places. So if I go to my calculator and I calculate 6 minus, I like to put it in parentheses just to be careful, 4 square root of 2 divided by 9 is approximately 5.37. So let's use our calculator to actually calculate the definite integral and see if we get the same thing. So go to math, go down to FN int, hit enter. Let's go back to the original, which we were integrating from 1 to 2, the function x squared times the square root of 1 plus x to the third with respect to x. All right, before we hit enter, let's hope we got it right. There we go. There's how you can check yourself. So now I know if I go back to the graph, the area under this curve from 1 to 2 is approximately 5.37. Exactly, with exact numbers, I'd say it's 6 minus 4 over 9 times the square root of 2. All right, so I hope this video helped. Go back to the beginning and look at how we used U-substitution to substitute expressions in to the integrand so that we can integrate very easily, very quickly using the power rule. If you need another example using U-substitution, please let me know in the comments. Or if something wasn't clear, if there were too many colors or not enough colors, I tend to love to use colors because it helps me show people where things go. So let me know if this helped. Let me know if you have any questions. If you want to continue getting the content, please subscribe to the channel. I plan on continuously releasing content related to all different levels of math. So make sure you subscribe to see that content. See you in the next one.